Okay, welcome to AD Mathematics. In this video, we are going to look at what sets are. Okay, basically, when we talk of a set is an irrational root expression that remains in radical form. Okay, so in this video, I presume you already know about rational numbers and irrational numbers. When we talk about a rational number, we mean any number at all that can be represented in the form a over b, where a is an integer and also b is an integer. So an example of a rational number, you can have 7 over 2 because 7 is an integer, 2 is also an integer. 10 over 5, the same reason, this is an integer, this is also an integer. Even whole numbers are rational numbers because when you have 4, let's say a number 4, you can represent it as 4 out of 1, where A is 4, B is 1. Okay, that was just a quick recap. And then when we come to irrational numbers, which is of interest today, we mean numbers which cannot be represented or which cannot be expressed in the form A over B. Example, when you have square root of 2, it will be very difficult for you to get or for you to represent this number in the form a over b, where a is an integer and then b is also an integer. So we say all those numbers in this family are irrational numbers. So now the key thing in the definition of the set was irrational, which we've understood, and then radical form. When we talk about radical, we mean the root, the root sign, yeah, and then any expression assigned to it. So it could be, an example could be square root of x plus 4, the cube root of 3 plus whatever. Yeah, basically that's what you mean by a radical. So now for a number to be called a set, or for we to classify a number as a set, we look at two things. What is it? One, the number must be what? An irrational root expression, and then it should be in the radical form. That is, radicals that represent irrational numbers are called what? Set. Very good. So, for instance, when you have the square root of 4, the square root of 4 is not a set because it can be simplified to get what? 2, right? And this 2 is not in its radical form. So basically, for when we simplify, or when you have the number and then you simplify it down, and then if it happens that it remains in its radical form, then definitely it qualifies to be a set. When you have square root of 3, square root of 3 is a set because this is the, in fact, this one you cannot simplify it down further. You are still going to get root of 3, right? So we call this one set. Okay, very good. So you can take reference from the notes. Okay, so now let's look at reduction of sets. Reduction of sets. Yes. So now we've looked at some of the examples of sets. We talk about the example will be 2 root 3. Um, let's say 7 root 9. Sorry, 7 root 10. Yes. Okay, so these are all examples of sets. Now we are looking at how we can reduce these sets in its simplest form. Basically, when you talk about reduction of a set in its simplest form, you basically mean express it yes. So sorry for the interruption. When we talk about reduction of sets, basically what we mean is that let's say we have a set root of x. Yes, and please mind you, anytime I use a variable, say x, I mean it's a number. Yeah, it's representing number. So when you have, let's say root of x is a set, right? Now to represent this set in its basic form, we mean express its express s in its factors such that there will be no perfect square. In other words, if we express x in its simplest form, or if we reduce x, it means x will not contain any factor which is a perfect square. Let's take an example. Let's say we have square root of 20, right? So here we can say square root of x, where x is equal to 20, right? But we know that 20 is equal to 5 times 4. So square root of 20 could be represented as square root of 5 times 4. Yes, I hope you do understand, right? And we know that there is this property, we will prove it along the way, but for now, let's know it. When you have square root of a multiplying square root of b, you are going to get square root of a times b, or yeah, the square root of a times b, right? So now with this one, square root of 5 times 4 is the same as square root of 4 times square root of 5. Mind you, the square root of any prime number is a surd. Yes, because it is also an irrational number which remains in the radical form. So now, what is square root of 4? Square root of 4 is going to give me 2. Yeah. In this lesson, when we talk about the root of a number, basically we mean the positive square root. Yeah, though square root of 4 is equal to plus or minus 2. We know that, but under this lesson, when we talk about the square root, we mean the positive square root, right? So what do we get? 2 root 5. Yes, we say root of 20 is the same as 2 root 5. But then root of 20 is not in its simplest form. Why? Because it contains a factor which is a perfect square. And what is that perfect square? That number is 4. So by reducing a set, we are representing it in its basic form, so that there are that particular number or expression has no perfect number. Sure. So when you simplify root of 20 in the simplest form, you're going to get root of 5. Let's take another example. Example 2. Let's say we have square root of 24. What is square root of 24? Basically, we all know that 24 as a number is equal to 6 times 4. So the key is that always when you are giving the number, try to represent it in terms of its factors. Look out for those which are perfect squares. Okay, so basically we could say then square root of 24 is equal to square root of 6 times 4. And by the property we just learned, we learned that um square root of a times square root of b is equal to square root of a times b, right? So this one we can split it to get square root of 6 times square root of 4. Now square root of 6 is not a rational expression, but square root of 4 is a rational, it will give us a rational number, right? So which means it's a perfect, and 4 is also a perfect square number, right? So square root of 4 is what? Is 2. So we have 2 times root of 6, and then we simplify it as 2 root 6. Don't worry, we'll learn some of the properties of 6 along the line. We'll learn them along the line. Let's take our last example, square root of example 3. Square root of 75. Basically, when you talk about what's the answer, we know that 75 could be expressed as 25 times 3. Yes, and then what happens? We can split it, square root of 25 times square root of 3. What's the positive square root of 25? We get what? 3. So we have 3 times root of 3, which is 3 root 3. Okay, so we've reduced this set to its what? Simplest form or basic form. And this number is a set because in its basic form, it remains in what? In its radical form. Remember, I said a radical expression has the root sign, not necessarily a square root, any root sign. It could be a third root, fourth root, whatever, and then a number or an expression assigned to that. So this one is a surd in its simplest form. Okay, so I do hope we get the simplifications of surd. Okay, um, yeah, there are some perfect squares that we have to note, perfect squares that we have to note carefully. Some numbers are perfect squares. So example is when you have root of 9, you are getting 3, right? So 9 is a perfect square number. 36, root of 36, you get 6. There are a lot. Square root of 144, you are going to get 12. So this one, you have to brainstorm them. Okay, keep them in head. You have to keep them in head as we move along. So now, let's look at one important thing: addition and subtraction of sets. We are going to look at addition and subtraction of sets. Yes. You see, before we go into the addition, subtraction, multiplication, and whatever, there is one thing that we have to know. One thing that has been established from the introduction is that set is also a number, right? It's a number. Basically, it falls under irrational number. Now, I want you to understand this from a mathematical viewpoint. You see, when we were in high school, I mean junior high school, you could represent any number with a variable. So you could say let x equal to, let's say, 10, right? Okay. So now I would like you to keep this in head, and then it will be useful as we move along. So let's say you have 3y, and then so let's say simplify 3y plus 4y. What do we do? This is, we can factor the y out, right? So we factor it out, and then 3 plus 4 giving us 7y, right? So basically we've been using this property always. 3y plus 4y, we are going to get 7y, and here is the proof. We can factor the y out and then write this, right? 7y. And basically when you talk about 7y, we mean 7 times y. Okay. Likewise, it's the same thing that happens with said. Before we can add and then subtract cells, remember we've done reduction of cells in its basic form, where we said when you have a set, let's say 24, you could simplify it as square root of 6 times 4, and then the square root of 4 can be found. So we say 2 root 6. Okay, so this is the square root of 24. The simplest form is this. So yes, before we could add or subtract set, this representation is important. Let's keep it in its basic form. Okay, so that was just a note. We are going to use it along the way. So let's say we have let's learn the properties now. Property number one. The property number one. When you have m root k multi m root k plus n root k, basically, what's the answer? Think about it. Think about it. Okay, so you could say, oh, let's represent k, let x equal to k, right? Very good. So it's more like we are having mx plus nx, right? And from basic algebra, we could factorize the x out, right? So we factorize it out, and then we have m plus n. Okay, so basically when we have m root k plus n root k, property number one, what are we getting? We are going to get, so here x is what? Oh, sorry, x is equal to root of k. So here it will be m plus n or multiplying root of k, right? Very good, very good, very good. Okay, let's move on to the next property. This is basic algebra. You just factorize it out and then you go your way. So the rule is that when you are asked to add set and then the expression inside the root, they are the same. Just look at the factor which is multiplying the set, or which is multiplying the expression in the root. So here m, here n. So you add them, m plus n, you get k. Yeah, you will look at example, don't worry. But for now, let's brainstorm the properties. Okay. Likewise, when you have m root k minus n root k, what are we getting? Yes, if you are using the same rule that we did, we could factorize the k out, right? So we factorize k out. So we have root of k multiplying m and then minus n. So this property we are going to get m root k minus n root k. We are getting m minus n root k. Yes, so these are the basic two properties that we need before we could add and subtract sets. Yes, so the first rule is whenever a question is given to you, what you have to do is simple. First of all, represent the particular expression in its simplest form or reduce that particular set. After that, you use these properties in terms of adding and subtracting. Okay, so let's look at example. So we have our first example, we have 5 root 2 plus 3 root 2. Yes, 5 root 2 plus 3 root 2. What are we getting? Basically, if you don't know this property, I don't want you to brainstorm it. I want you to understand. Here we could say root of 2 is a number. I hope you agree. Yeah, that it is an irrational number doesn't mean it's not a number. Irrational numbers are also they are also numbers, right? So root of 2 is here. Root of 2 is here. We could factorize root of 2 out, right? So we factorize it out, root of 2, and then basic algebra we get 5 plus 3. Yes, and with elective mathematics, in fact, if you want to really thrive in this particular subject, you have to note the reverse of what you do. Yes, so sometimes a question will be given to you in this form, and then you will be asked to expand it. You use your basic algebra, treat this as a variable, and then so let's say we have x multiplying 5 plus 3. What are we getting? 5x and then plus 3x. Okay, that's just along the way. I just want you to know that the reverse could also be given to you. So let's go back to our question. 5 plus 3 is what? We are getting 8. So root of 2 times 8. What are we getting? 8 root 2. Basically, when you talk about 8 root 2, we mean 8 times root of 2. Just like in basic algebra, where let's say A is a number, B is also a number, and then we've been asked to find A times B. What do we get? AB, right? So the same thing. Root of 2 is a number, 8 is a number. When they are multiplying, you will get AB. So 8 root 2. Yes, that's how it works. Let's look at example 2. We have 4 root 7 plus 9 root 7. Now I believe you can see the shortcut now. Just ignore the roots because they are the same. So 4 plus 9 is what? 13. And then you bring the root 7. Yes, and we've already done the proof. Okay, let's um do some example on the subtraction. Okay, so let's say we have um 5 root 11 minus 3 root 11. The same algebra, we factorize the root of 11 out, right? Factorize it out, and then what's left? 5 minus 3. This expression, we can simplify this to get 2. So we have root of 11 times 2, giving us 2 root 11. Okay, I believe you understand. One example, and then we increase the complexity. Let's say we have 2 root 5 minus 5 root 5. What are we getting? Factorize the negative 5 out. Okay. what will be left? 2 minus 5. Okay, so what do we get? Negative 3 root 5. Okay, I believe we are all getting it now. So the rule is very, very simple. You go back to this property. The property is basically saying just ignore the k, add these two numbers, and then multiply by the k. Yeah, basically that's basic algebra. Okay, so let's increase the complexity a little. Let's say we have question. Let's solve it here. Let's say we have 3 root 8 plus 3 root 200. Yes, let's look at this. Okay, no, let me. Okay, so we have 3 root 8 plus 3 root 200. Now, if we go back to our previous examples, remember this property assumes that m root k is in its simplest form, or k is in its simplest form. That is, it doesn't contain any perfect square. 8 factor, there is no factor of k that is a perfect square. That's the assumption. So you could see that the examples we saw here, all the expressions in the roots are all in their simplest form, right? And I told you before you could add and subtract any set, you have to reduce the number to its simplest form. So you ask yourself, is 8 in its simplest form? Okay, here you start. If your mathematics is not good, you are going to suffer here. So now, what are the factors of, or is there a factor of 8 which is a perfect square? So you could list the factors of 8. We have 1, 2, 4, and 8, right? So you ask yourself, is there a factor of 8 which is a perfect square? And the answer is yes, 4. 4 is a perfect number, right? Okay, mean the square root of 4, you are going to get 2. Okay, so meaning this is not in its simplest form because there is a factor which is perfect. Okay, now let's look at 200. What is 200 giving us? 200, what are the factors of 200? We have 1, 2, I think 4, 5, if I'm right, 6, 7, 8. I think you are getting 10. You will get 20, whatever, and it goes on and forth, right? Now there's also 4 here. It is also a perfect number, right? So meaning root of 200 is not in its simplest form. So here you see when the question is given to you in this form, ask yourself, are the numbers in their simplest form? If yes, then there's nothing you could do about it. But if no, try to reduce it to its simplest form and then evaluate it. So now let's focus on our question. You know that 3 root 8, this is the question, plus 3 root 200. It can be represented as 3 square root of 4 times 2 plus 3 square root of 2 times 100. Yes, I hope you are following. Okay. Um, okay. So now let's simplify this expression. What do we get? Mhm. Now, remember I told you that when you have square root of a times b, you can split it and get root of a times root of b. I said we will prove it, don't worry, but for now keep it in head. So here we can split it. So we get 3 multiplying square root of 4 times square root of 2 plus this 3 multiplying this expression root of 2 times root of 100, right? Okay, so what do we get? 3 multiplying square root of 4 is what? Is 2 times what is square root of 2 is said. We cannot write it in the form A over B, right? So we leave it as such. Plus 3 multiplying, what's the square root of 2? Cannot simplify. Times. I'm not saying the square root of 2 does not exist. Please take note. I'm not saying the square root of 2 does not exist. If you go back to the introductory video, I think you are going to get it. You cannot represent it as a rational number, right? Well, the square root of 100 is 10. Okay, so we get 3 times 2, 6 times root 2 is 6 root 2 plus 3 times 10, 30, right? 30 root 2. So now if we reduce it to get 6 root 2 plus 30 root 2. Okay, so can we apply our property? The answer is yes, we could do that. This is root of 2, this is root of 2. You can factorize the root of 2 out. So you get root of 2, 6 plus 30. Yes, this is an introductory video. That's why I'm doing all this. As we move along, I'm just going to write the answers. 6 plus 30 is what? 36. So we have 36 times root of 2. This is 36, this expression. And this is root of 2. So what do you get? 36 root 2. And I've already told you that 36 root 2 is the same as 36 times root of 2. Okay, so you get this as your answer. And yes, I would like to keep this video short. I wouldn't take much of your time. Yes, so let's solve more examples, and then in the next video we look at conjugate set. But then let me solve some examples with you. We have root of 50 plus root of 32 minus square root of 162, right? So example, is it 4? Okay, let's say 4, right? So now there is a rule of thumb. There's a shortcut for doing this. I will teach you, especially for people preparing for your WASI. Okay, before that, let's solve this one manually. The normal method. Okay, so root of 50, I could see that, 50 can be represented as 2 times 25. Square root of 50 is the same as square root of 2 times 25 plus square root of 32 is the same as 4 times 8 minus this one. You see, it's not you are not forced to write this one straight. You could I mean write this one in terms of 8 factors. So here I know that this one is an even number. I could write 2 times. So 2 goes into this how many times? 81. Right. Good. So let's see. So 2 times. So this one, I know that this one is a perfect square. I could bring it out to get square root of 25 is 5. So I have 5 root 2 plus, what's the square root of 4? The square root of 4 is 2. I have 2 root 8 minus, what's the square root of 2? It's still square root of 2, because in its simplest form, we get this. We cannot write it in a form A over B, right? It's a set. This is a set. Root of 2 is a set. So we leave it in. Yeah, so anytime we get a set, we leave it. We don't simplify. I know root of 2, you will get a decimal, but we are not interested in that. It's a set. What about 81? You'll get 9. Yes. Now ask yourself, this expression that I have, is it in its simplest form? So let's take it one after the other. Root of 2. Is root of 2 in its simplest form? Or is 2 in its simplest form? Yes. What about 8? Is 8 in its simplest form? No, because 8 can be represented as 2 times 4, right? So we do that. Root of 2 plus 2. We get 4 times 2, right? Minus 9 root 2, right? Okay. So what do? We can find the square root of 4, which is 2. So we have 5 root 2 coming from this expression plus, now the square root of 4 is 2. That 2 will multiply these 2, giving us 4 root 2 minus 9 root 2. Do we have common factors? Yes, root of 2, root of 2. So we can simplify them. We can factorize root of 2 out, and then we have 5 plus 4 minus 9. Yeah, it's the basic problem that we've done. And then 5 plus 4 is what? It's 9. 9 minus 9 is 0. So basically we have 0 times root of 2. And what's the answer? 0. Okay. Let's solve one example, and then I'll show you the trick that I was talking about. You see, there is a different way you could solve this same question. Let's take this same question again. The question was root of 50, oh sorry, plus root of 32 minus root of 162. Right, now I know that 50 is going to give me 25 times 2 plus root of 32. I know that this one is going to give me 16 times 2 minus I know that this one is also going to give me 81 times 2. 81 times 2, right? So now here, this one, you can find the square root. So we get 5 root 2 plus square root of 16 is 4. 4 root 2 minus square root of 81 is 9. 9 root 2, right? And then we factorize it out, we get 5 plus 4 minus 9 times root of 2, and we get 0 root 2, right? You see, this is different from the first one that I did, but you see, we arrived at the same answer. Here, I was able to fish out that 32 is the same as 16 times 2. Yeah, but here I took I did it in a I don't know, in steps, so no matter how you do it, you don't worry. It's not by force for you to capture that, oh, when I see 32 I have to write it 16 times to know. Just reduce the number, express it in terms of multiplication of any two factors. So after expressing them, then you ask yourself, here we have 2 root 8, so we asked ourselves, is 8 reducible? Very good. So just write it as a factor of 2, as a product of two numbers, excluding one, and the excluding one, as a product of any two numbers, and then you try to find out, okay, so these two numbers that are represented, are they still reducible? So you reduce them till you get your final answer. I know this is a challenge, especially if you are trying to um, learn it from scratch. If you are trying to learn said something like square root of 200, someone will say, oh, this is 2 times 100 is going to give me 200, so I'll do it this way. Another person is also going to say, oh, 4 times 50 is going to give me the same square root of 200. Another person is also going to say, oh, this 200 I know is equal to 10 times 20. Whatever the case, whatever you do, you are right. But always make sure that reduce whatever you get to it what simplest form. So let's take the first one. 2 times 100. Is 2 in its simplest form? Yes, because root of 2 is a said. Is 10 in its simplest form? Then you ask yourself, no, because I can find the square root of 10. Therefore, I could say then the simplest form will be 10 root 2. Please, do you get it? Okay. Is 4 in its simplest form? You ask yourself, no, I could. Why? Because I can find the square root of 4, which is 2. So I have 2 roots 50. Someone is saying, but 2 root 50 is not the same as the 10 root 2 that we add. Very good. So after getting the 2 root 50, ask yourself, is 50 in its simplest form? No, I can also express 50 as a product of two factors, which is someone will say 2 and 25. So we have 2 roots. 50 is going to give me 2 times 25. Is 2 in its simplest form? Yes, 2 is a set. Is 25 in its simplest form? No. We could find we can find the square root of 25. What is the square root of 25? We get 5, right? So 2 times that 5, 10. Root of 2. Okay. So you see, 10 root 2, 10 root 2. Okay, here, can we find the square root of 10? No. Can we find the square root of 20? No. Now, can we reduce 10? Yes. Are you sure? Yes. 10 can be represented as 2 times 5. Oh, okay, very good. What about 20? 20, oh, 5 times 4. So you see, um, what do we have? Okay, so we have um 5 times 5, right? 5 times 5 is 25. This one you have to be fast. 5 times 5 is 25. And the square root of 25 is 5. Basically, there is also this property. Remember, I told you will learn them one after the other, probably in the next video. Root of a times a is going to give you what? A. This thing that you are going to introduce in the next video, don't worry about it. But then, so this one you can say we have 2 times 25 times 4, right? Okay, can we reduce 2? No. Root of 2. Can we reduce this one? 5. Can we reduce 4? Yes, 2. 5 to 10. Root 2. So, whatever the method you use, you are always going to arrive at the same answer. Okay, so this is it. I would like to end here. So basically, we introduce sets, we look at simplifications of sets, and then we did addition and subtraction of sets, and how we proved that property, that is root of n root m plus, I think, was it, let's say p root m is equal to n plus p root m. Yeah, we did this, and see you in the next video. If you have any question, drop it in the comment section and I'll do well to reply. Bye bye.